Hello everyone, my name is Michael Jian and I will be going over the first 10 problems. Question 1. Every chair in the meeting hall has 4 legs. There are 336 chair legs in the hall. The number of chairs is what? So you see that this is a simple division problem. 336 chair legs over 4 legs is equal to 84 chairs. So the answer would be A. Question 2. Vivian bought a number of toys from a factory for X dollars each and put them for sale in her toy store. The marked price was $100. During the holiday, she offered 20% discount. After that, Vivian could still have 25% profit. Find X. So first of all, we notice that she offers 20% discount. 20% discount means that there is 80% of the original price left and 80% of 100 is equal to $80. Then it says that Vivian could still have 25% profit if she sold a toy for $80. This means that 125% X is equal to $80. So 125% can also be written as 5 over 4 X, which is equal to $80. So solving for X, we get X is equal to 80 times 4 over 5, which is equivalent to 64, giving C as the answer to this problem. 3. Estelle is making decorations shaped like the 8-pointed star shown. She folds a square of paper to make a triangle with 8 layers as shown. How could she cut the triangle so that the unfolded shape is a star? So to solve this problem, we trace out the pattern that she will have to cut out on the given pieces of paper as shown. So first of all, step 1's cut will look like this. And after she folds it, the paper will look like this. After folding again, the paper will look like this, where the shaded portions are the regions that will be cut. So most closely matches our final result over here would be B. And thus B is the answer to question 3. Question 4. A rabbit and a hedgehog participated in a running race on a 550-meter long circular track, both starting and finishing at the same point. The rabbit ran clockwise at a speed of 10 meters per second, and the hedgehog ran counterclockwise at a speed of 1 meter per second. When they met, the rabbit continued as before, but the hedgehog turned around and ran clockwise. How many seconds after the rabbit did the hedgehog reach the finish? So first we draw a diagram. So this is the circular track, and let this be the start. So the rabbit runs clockwise at a speed of 10 meters per second, as shown by the blue line. Meanwhile, the hedgehog runs at a speed of 1 meters per second counterclockwise. And we meet up over here. So we notice that the combined speed of the rabbit and the hedgehog is 10 plus 1, which is equal to 11 meters per second. And there are 550 meters. So 550 meters over 11 is equal to 50. So it takes them 50 seconds to get to the point where they meet. So now we want to find out how far this distance is from the start. Since the hedgehog traveled 50 seconds and it moves at 1 meters per second, then this point must be 50 meters from the starting point. So when the rabbit continues out before, it continues running the last 50 meters at a speed of 10 meters per second. So it takes 50 over 10, which is equal to 5 seconds to finish. Meanwhile, the hedgehog turns around at the 50 meters and does it again. It takes 50 over 1, which is equal to 50 seconds to finish. So the hedgehog reached the finish 50 minus 5, which is equal to 45 seconds after the rabbit. And this gives B. For a positive integer n, Let Sn be the sum of the digits of n. For example, S of 2024 is equal to 2 plus 0 plus 2 plus 4 equals 8. Which of the following numbers satisfies the equation? N plus S of n plus S of S of n plus S of S of S of n is equal to 2024. So we go to the answer choices one by one to see whether they work. When n is equal to 1989, then the above expression gives 1989 plus the sum of its digits, 27, plus the sum of 27's digits, 9, plus the sum of 9's digit, 9, which is equal to 2034, which is too big. Now for B, when n is equal to 1998, 1998 plus the sum of its digits, 27, plus the sum of 27's digits, 9, plus the sum of 9's digits, 9, is equal to 2043, which is also too big. Now we see what happens when n equals 2009. 2009 plus the sum of its digits, 11, plus the sum of the digits of 11, 2, plus the sum of the digits of 2, which is also 2, is equal to 2024. N equals 2009 is the answer, which is C. Question 6. Maggie used K-congruent rectangular pieces to form the following square. What is K? Consider a small rectangle first. Let the length of the rectangle be X and the width of the rectangle be Y. Since the following square has the sine terms equal, we can put them in terms of X and Y. The square is 3x long and 2x plus 2y wide. Because the sides of a square are equal, we get the equation 3x is equal to 2x plus 2y. So x equals 2y. So now we can draw lines on the square to split it up and then count how many there are total. So by counting all of the smaller rectangles in there, we notice there are a total of 18 congruent rectangular pieces, which gives D as the answer. Question 7. In a survey, people were asked to name their favorite fruit pie. The pie charts show the outcome. The angles shown are exact with no rounding. What is the smallest number of people who could have been surveyed? So first, we compare the ratio of the portions of people who chose each piece of pie. So the ratio will be in terms of apples to cherries to rhubarbs to plums. So looking at the degrees of a circle, we notice that there are 140 degrees of apple for every 108 degrees of cherries, for every 72 degrees of rhubarbs, for every 40 degrees of plums. So now we want to simplify this ratio. We notice that every single number is divisible by 4. So we divide them all by 4 to get the ratio 35 to 27 to 18 to 10. So we notice that none of these ratios can be simplified further. So we can let each people be 1 dean in here. Then summing them up, there are a total of 90 deans. So at minimum, there could be 90 people, which gives the answer choice D. Question 8. On the table, there's a tower made of blocks numbered from 1 to 90. Bello takes blocks from the top of the tower, 3 at a time, to build a new tower, as shown. When he has finished building the new tower, how many blocks will be between the blocks numbered 39 and 40? So I notice a pattern here. Every 3 blocks, there's a pattern. Where is the largest number a multiple of 3, followed by the number less than it, and then the number less than it by another 1. So after 3, 2, 1, we have 6, 5, 4, 9, 8, 7, and so on. So now 39 is divisible by 3. So we write 39. Right below it would be 38 and then 37. But right below 37 would be the multiple of 3 that is greater than 39, which would be 42. After 42 is 41, and then 40. So between 39 and 40, there are a total of 4 blocks in between them, which gives D. Question 9. I hear that dogs age 7 dog years every year. My dog Ruby was born on my 9th birthday. 4 years from now, on our birthday, Ruby's age in dog years will be exactly 4 times my age in normal years. How old am I now? So let my current age be X. Then the dog's current age, since it was born 9 years after, but ages 7 times as fast, would be 7 times X minus 9. So 4 years from now, my current age will be X plus 4. And the dog, because it ages 4 times as fast, would be 7 times X minus 9 plus 4 human years times 7, because dog years. And this is 4 times as much as my current age. So 4 times X plus 4 is equal to 7 times X minus 9 plus 4 times 7. So expanding both sides, we get 4x plus 16 is equal to 7x minus 63 plus 28. Then simplifying both sides, we end up with 3x is equal to 63 plus 16 minus 28 equals 51. So x is equal to 17, and I'm currently 17 years old, which gives E. Question 10. Some edges of a cube are to be colored red so that every face of a cube has at least one red edge. What is the smallest possible number of edges that could be red? So first we draw a cube. Notice that if we color one edge red, let's say this one, then there are exactly 2 faces of a cube that are touching it, which are highlighted as shown. So then the smallest possible number of edges that could be red could be 6 faces divided by 2 faces per edge, which is equal to 3 edges. And to check this, we can find out which other edges that could be colored red to make it work. So it turns out if we color this edge also red, along with this edge, then every face of the cube has at least one red edge. And so the answer is 3, which is B.
Hello everyone, the following part is the solution videos for questions from 11 to 25. Let's do question 11. Here we have 20 identical containers. They are completely vacuum sealed. So at the beginning, container 1 has 64 kilogram special gas. And then when container 1 is connected to container 2, so the gas will be equally shared between these 2 containers. So finally, each of them will have 32 kilograms. And then we disconnect and we connect container 2 and 3. So each of them will share 1/2 of this 32 kilogram. So that becomes 16 and 16. The next step, we equally share 16 kilograms between 3 and 4. So it's 8 and 8. Then between 4 and 5, they share this 8. So it's 4 and 4. Between 5 and 6, they share this 4 kilogram from container 5. So 2, 2 finally. And lastly, we have 1 kilogram in 6 and 1 kilogram in 7. They share that initial 2 kilogram from container 6. So after that, if we connect 7 and 8, they will share this 1 kilogram. So 1/2 and 1/2, and keep going up to container 19 and 20. So we see that in the later process, we don't change the amount of gas in container 6. Because the question is asking how much in container 6. So container 6 will always have 1 kilogram. So the answer is A, 1 kilogram. Question 12. There are 5 elves standing along a circle. Some elves are always telling the truth, some are always lying. Now everyone says there's at least one liar among the two standing next to him. The question is how many elves are liars? Let's see. Suppose we have a liar. Suppose we have a liar, so that means his statement is false. Now the statement says that there's at least one liar among two standing next to him. So if it's a liar, that means this statement is false. That just means the 2 elves standing beside him are both honest. Honest elves on one side and honest elf on the other side. That's the situation for a liar. Okay, now for an honest elf. For honest elf, it means the statement is true. That means there will be a liar on either side of this elf. So an honest elf is next to some liar. But for a liar, it's next to, on both sides, both are honest elves. So consider that we see a liar is always isolated. Now, if we consider this question, we have five elves. So there are, now we have 5 elves. So there are at most 2 liars. So because if you have 3 or more liars, we cannot isolate every liar. So there are at most 2 liars. Now let's consider 2 scenarios. If we have just one liar, let me use cross to mean a liar, and the others are all honest. In this way, we have a contradiction because we see that for honest elf, it must be next to a liar, which is not true in this picture. This is a contradiction. This is a contradiction. Because this honest elf is next to, on both sides are honest elves. So we have to take the other scenario. There are 2 liars. And these 2 liars cannot be next to each other. So let's see, we have liar here and another liar not next to him. Should be here. Doesn't matter if for the other one, doesn't matter because it's symmetrical. Let's see. For this scenario, it works. For other 3 elves, they are all honest. This is consistent to our requirements. Every liar is isolated. Every honest elf is next to some liar. So the answer to this question should be 2. Question 13. The maximum capacity of a theater is 2,000. Suppose that the number of seats taken for a new movie is uniform between 1,001 and 2,000. So let K be the number of seats taken. So K could be 1,001, K could be 1,002, up to K could be 2,000. 1999, 2,000. Now each case appears equally likely. So each case appears with probability 1 over 1,000. With probability 1 over 1,000. With probability 1 over 1,000. 1 over 1,000. Okay. Now the question is asking, what's the probability that at least 20% of the seats are empty? Now let's see how many corresponds to 20% of seats. 20%, there are totally 2,000 seats. So 20% means 400. So the question is asking What's the probability? We have at least 200 seats not taken. So that means we have at most 1,600 seats taken. At most 1,600 seats are taken. Okay, this is at most 1,600 seats are taken. But in our case, the possibilities are between number of seats are between 1,001 and 2,000. So that corresponds to these 600 cases. About 100, there are 600 cases happen. So the probability corresponds to this 600 cases, and each case with probability 1 over 1,000. So the answer for the probability is 600 over 1,000, which is 3 over 5. The answer is 3 over 5. Question 14. Two squares of different sizes are drawn inside of equilateral triangle. In the picture, one of these square lines on one of the sides of the triangle. What's the size of the angle marked by the question mark? So we can view this question mark as an angle in a pentagon. Let me show this pentagon. This is the pentagon. A, B, C, D, E. So A, B, C, D, E is a pentagon. Now for pentagon, we know how to compute the sum of these 5 angles. The sum of 5 angles equals 5 minus 2 times 180. It's 540 degrees. Okay, 540 degrees. Now, if we look at this 5 angles, we can figure out every angle except this question mark. So this 540 corresponds to angle A plus angle B plus angle C, angle D, and angle E. Now, angle A is from the equilateral triangle, so it's 60 degrees. Angle B is given as 70 degrees. Angle C is 360 minus 90, so 270 degrees. Question mark is angle D. Angle E is obviously 90 degrees. So in this way, we can solve angle D to be 50 degrees. So the answer to this question is 50 degrees. Question 15. Emily placed 2024 dominoes in a row. Her sister Elizabeth removed every 8th domino. Then her brother Kyver removed every 7th domino. Her friend Doris removed every 6th domino. So at last, Emily removed all the remaining n dominoes. So what's the sum of digits of n? So here, a key remark is that we have 2024 is divisible by 8. 2024 is divisible by 8. Actually, 2024 is 8 times 253. So it's divisible by 8, which is important here because in the first step, Elizabeth removed every 8th domino. That just means how many dominoes left will be 2024 times 1 minus 1 over 8. It's integer. In other words, it's 2024 times 7 over 8. Now, because 24 is divisible by 8, this number is divisible by 7. Divisible by 7. Now, if we move to the second step, her brother Kyra removes every seventh domino. So we just times 1 minus 1 over 7. We just times 1 minus 1 over 7, which is equivalent to, this is times 6 over 7. Okay, and this number is divisible by 6 by 6. Now, last step, when Doris came, Doris. So Doris remove every 6 domino. So we just times 1 minus 1 over 6. That's the number of dominoes left. Times 1 minus 1 over 6, which finally we have the answer for n. So this is the value for n. Now we can see that we can cancel 7, 6, and that gives the value of n. So this is 253 times 5. 253 times 5 is going to be 1,265. So this is the value of n. Now the sum of the digits of n is 1 plus 2 plus 6 plus 5. That's our answer. The answer equals 14. Question 16. We have this 2 by 2 by 2 cube and 1 by 1 by 1 cube removed from it. We have 2 copies of such shape that they inverted and put together to get a new shape. What's the surface area of this new shape in square centimeter? Now we can see that this new shape has totally 10 faces. Okay, 10 faces. Let's count each face. First, let's see the top and the bottom. They are congruent. For the top, right, the top equals the bottom. They are congruent. They are basically it's like we have 2 squares removed at 1 by 1 square. So 2 square, each square is 2 by 2, but we remove a center 1 by 1 square. So that's the area. The area equals 7. Okay, the top equals bottom equals 7. And then we consider the sides. Okay, the vertical faces. There are 8 such faces. Okay, so we can consider the front 2 faces first. The front 2. The front 2 is congruent to the back 2. So right here, front 2 faces is congruent to the back 2 faces. And that is equal to 2 squares. Each square with the measure 2 by 2. So each has the area 8, the front and back. Wait, I don't mark back. So finally, we consider the side. We consider the side. We have the left side and the right side. Left view, right view. Now let's imagine what it looks like because it's not fully shown in the picture. We can actually sketch that. So here we have a vertical line. Okay. Left equals right. Left equals right. Each part we have 2 faces. And the shape is like 2 half square, 2 half square. So the measure is 1, 2, okay, 1, 1, 1, 2. So each part, the area is just 4. Okay, it's 4. So we can add them together. Total. What's the total? We have top plus bottom. So top times 2. Front and back, 8 times 2. And left and right, 4 times 2. It's 14 plus 16 plus 8. Totally, we have 38. We have 38. That's the surface area. Question 17. The product of the digits of the positive integer n is 24. Which of the following could not be the product of the digits of n plus 1? So let's first consider what are the digits of n, which are the factors of 24. So we discuss the factorization of 24. It could be the following cases. First, let's consider without 1, because we can multiply arbitrary many ones. So 24, could it be 3 times 8? It could be 4 times 6. It could be 2 times 3 times 4. It could be 2 times 2 times 6. It could be 2 times 2 times 2 times 3. Possibly there are some ones, okay? We can multiply any number of ones. For example, we have ones, or a lot of ones. We may have some ones, possibly. Like that, okay? So let's consider n plus 1. What could be the possible number for n plus 1? N plus 1, basically, we add 1 to the ones digit. Okay, here, or for all the cases, we don't have the digit 9 in the factorization. So we can just add 1 digit to some number when that number is the ones digit. For example, for 3 times 8, it could be 3, 8, or 8, 3. So that means we can add 1 to 8, or we can add 1 to 3. So that becomes 39 or 84. Now let's discuss all possibilities to get the following cases. Now for A, it's possible to get 27 because 27 is equal to 3 times 9. Okay, 27 is 3 times 9. But 9 comes from 8 plus 1. So we can view this as plus 1 times 3. So that means if n equals 38, it works. For B, it's 28. 28 equals 4 times 7, right? 4 times 7. 4 times 7 can be viewed as 4 times 6 plus 1. So when A equals 46, that works. For C, C is 32. If you factorize 32, it can be viewed as 2 times 2 times 2 times 3, 2 times 4, okay? 2 times 4. So that's 32. Now, we can view 4 to be from 3. So this can be viewed as 2 times 2 times 2 times 3 plus 1. In this case, we can choose n to be 2, 2, 2, 3. For D, it's also possible because 36 is equal to 6 times 6 or 2 times 3 times 6. Let me write 6 times 2 times 3. It can be viewed as 6 times 2 times 2 plus 1. So it works when n equals 622. And D, okay, E is not possible. Okay, so in this question, the answer should be E. Let's discuss why E is not possible. Why it's not possible? Because if it's possible, 42 should be factorized into 7 times 6, or maybe 7 times 2 times 3, right? 6 or 7 times 3 times 2. And you know that here we have number 7, which cannot be further factorized. 7 is a prime number. So 7, in our factorization of 24, we don't have 7. So the only possibility for 7 is 6 plus 1. 6 plus 1. So we must have the unit digit of n to be 6 plus 1, we get 7. That's the only possibility. So 42 can be viewed as 6 times 6 plus 1, or 2 times 3 times 6 plus 1. But there's a problem. This problem concerning is 6 or is 2 times 3. Because here we already used the 6, right? We already used the 6. Other than that, we don't have other 3's in the factorization of 24. No more 6 or 3 in 24. So that's why it's impossible. So that's why this is impossible. Impossible. So the answer here is E, 42. Question 18. We have 15 by 15 square of origami paper that's gray on the top and white underneath. The top left corner is folded, like the picture shows, such that this white region and the gray region are equal in the areas. The question is, what's the X in this picture? What's the X in this picture? Now let's recover this picture to the original square. If we get back to original square, like this figure, let me label A, B, C, D. Say A, 4 to E, and the crease intersect here at F. So obviously, because we fold A, D, F to E, D, F, we should have these two triangles congruent. A, D, F is congruent to E, D, F. Congruent means they have the same area. They have the same area. So let me mark ADF, the area to be 1, DEF area to be 2, and the shaded part, the gray part, let me call it 3. In the question, it says that these 2 are 2 and part of 3, they are equal in the area. Also, we know area 1 equals area 2. In other words, those 3 parts, they have the same area. And that means each one shares 1/3 of this square's area, A, B, C, D. And the square's area is computable, which is 15 square. So 15 square divided by 3, we get 75. In other words, each part here, 1, 2, 3, each part shares 75 square centimeters. And now we can solve X. First, we need to we look at a 1, it's a right triangle. The area is 75. It can be expressed as 1/2 times AD times AF. But we know AD equals the side of the square, which is 15. So from here, we can solve AF. AF equals 10 centimeters. Now, in this way, we can solve BF, which is the answer. X is BF, but BF can be viewed as AB minus AF. AB is the side length, 15 centimeters. AF, we just got it to be 10. So the answer is 5 centimeters. The answer here is 5. Let's do question 19. Here we have the addition of two 4-digit numbers. LOVE plus 2024 equals AMC8. Those letters are different digits. We should maximize LOVE and find the corresponding values of A, M, and C. So here, from the 1st digit, we can easily determine E has to be 4. E plus 4 equals 8. That implies E can only be 4. That's for sure. Now, in order to maximize this number, this is equivalent to maximize the sum. And to maximize this 4-digit number, we should to maximize the highest digit A. we should maximize 8. Okay, so the largest digit is 9. So we should let A to be 9. So A plus 9. Accordingly, we see that L should be 7. L should be 7. Here, let me argue why L has to be 7 because the reason is that because A equals 9, because those letters are different, that implies O should be less than 9. O cannot be 9, otherwise two letters are same. So that means M equals O plus 1 and with no carry. So there's no carry from 100th digit to 1000th digit. That's why L plus 2 must be 8. That means L equals 7. That's the argument. Now we think about what's the largest value of O. Largest O. Now first we already know O is less than 9. O is less than 9. So we try to discuss the largest possible values that could be O. So first O cannot be 9 because A equals 9 implies O cannot be 9. Also, O cannot be 8 because M cannot be 9. So that means O, because M is O plus 1, so O cannot be 8. And because L is already 7, that means O cannot be 7. And L equals 7 also implies M cannot be 7, which implies O cannot be 6 because M is O plus 1. So in this way, we have that O, the largest O, should be 5. The largest O should be 5. And there's no contradiction. And accordingly, M equals 6. M equals 6. Now, okay, we know E equals 4. So the largest possible value for V should be 8. Okay, V should be 8. So in this way, we have a 7584 plus 2024 equals 9608. Okay, that's the largest possible values for AMC. So A plus M plus C is equal to 15. It's 9 plus 6 plus 0 is 15. This is our answer. Question 20. So in this question, we should determine R so that the circle with radius 2 equals this sector with radius and the arc length equal to R. They have the same area. Now let's find the formula to express the area for this sector. So a sector is viewed as part of a circle. Here we have the sector is radius R. Also the arc length is R. Let me mark the central angle to be theta. So the area for the sector is equal to theta over 360 degree times pi r squared. Now on the other hand, theta over 360 degree is also the ratio between the arc length and the circumference. The arc length is r. The circumference is 2 pi r. So theta over 360 degree is equal to 1 over 2 pi. We apply that here to the right. So this is 1 over 2 pi times pi r squared, which is equal to 1/2 of r squared. Now basically we should have 1/2 of r squared equals the circle's area. The circle's area is pi r squared, which is 4 pi. So the equation here is 4 pi equals 1/2 r squared. Now we can solve r to be square root of 8 I, which simplifies to twice of root 2 pi. That's the answer here. Question 21. Here we have 6 integers. We calculate their mean and the range. Now we add a new number, the 7th integer, such that the range does not change, but the mean becomes an integer. What's the new number? What's the new mean? All right, let's first add up these 6 numbers. 3, 4, 9, 11, 14, 20. It sum up to 61. Suppose let the 7th number be x. Okay. So the requirement is that first, the range does not change. The range does not change. That just means x must be between 3 and 20, because x is a different number. So it's between 3 and 20. The second requirement, the new mean is an integer. Let's calculate the new mean. The new mean is the sum is 61 plus x. There are 7 numbers. I divide this by 7. So this is an integer. In other words, 61 plus x is divisible by 7. We're going to discuss what are possible values of x. All right. First case, 61 plus x may be 63 because that's divisible by 7. So in this way, we got x equals 2. But this doesn't work because x must be bigger than 3. What we got is 2, so that's too small. Now, second case, 61 plus x may be 70. In this case, you can solve x equals 9. It doesn't work either because we already have 9. We should have x not equal to 9 because there's a 9 already. The number should be different. Now, third case, 61 plus x equals 77. Now, in this case, we have x equals 16. X equals 16, it works. It's a new number. And it doesn't, it's between 3 and 20, so it's good. Let's check if we can find other numbers. If it's bigger, 61 plus x may be 84. The next number, that's divisible by 7. So in this way, you have x to be 23. This doesn't work because it's too big. And then we can see that if we change 84 to bigger multiples of 7, x is even bigger and they don't work. That's why here the value for x must be 16. The new mean must be 77 over 7, which is 11. So the answer to this question is 11. Question 22. What's the smallest positive integer little n so that this big number 4 repeats n times is divisible by 396? Let me denote this big number by k. And we see that 396 can be factorized into 4 times 9 times 11. So the question requires k to be divisible by 396. So let me denote it this way. K is divisible by 396. This is equivalent to say k is divisible by 4, divisible by 9, and divisible by 11. Three parts. Now, if you check each part we will find the requirements for the little n. First, k is divisible by 4. This is automatically true. True for any n. Because the number consists of 4s, so it's automatically divisible by 4. And next, it's divisible by 9. The divisibility test for 9 is the digital sum is divisible by 9. So that's equivalent to say the digital sum is divisible by 9. Here, it's pretty easy to solve the digital sum. There are n 4s. So the digital sum is 4n. 4n is divisible by 9. Now 9 and 4 are co-prime. So 4n is divisible by 9 is equivalent to say n is divisible by 9. So we require n is a multiple of 9. Finally, we consider k to be divisible by 11. The divisibility test for 11 is that the alternating sum is divisible by 11. Alternating sum is divisible by 11. In other words, we should have 4 minus 4 plus 4 minus 4 plus 4, like that. This alternating sum is divisible by 11. Now, because all the digits are 4s, so this alternating sum, there are only two cases. One case is that when n is odd, and the alternating sum is equal to 4. Second, when n is even, so this 4 plus minus, they cancel each other, it's 0. So obviously, we can see that only n equals even works. We should require n to be even. All right, combine this requirement. So we should have n divisible by 9, and at the same time, n is even. Based on this, the smallest n should be 18. Should be 18. The answer is 18 here. Question 23. We assume ABCD is a square and the side length AB is 4. AB equals 4, BC equals 4, CD equals 4, AD is also 4. And BFG is a rectangle. It's given that EF equals 5. EF equals 5 because it's a rectangle. EF equals 5. That implies BG is also 5. BG equals EF equals 5. And then we can quickly solve the right triangle BCG. In the right triangle BCG, we have BG, the hypotenuse, equals 5. We have BC equals 4. So very quickly, we can solve CG. CG squared plus BC squared equals BG squared by Pythagorean theorem. So we know CG equals 3. G equals 3. And the question here is asking for EB. EB. Now we try to relate EB and something we know. Here we know BCG, everything about BCG, the sides. So we try to relate BE and the BCG. Here we notice that triangle BEA is similar to triangle BCG. Here, let me justify that. First, we have that both triangles are right triangles because angle E equals angle C equals 90 degrees. C equals 90 degrees. And also, we should find another pair of equal angles. Let me mark the angle EBA to be angle 1. let me mark this to be alpha. Angle ABG to be angle beta. Angle GBC to be angle gamma. Okay, so we note that angle alpha plus angle beta equals 90 degrees from the rectangle. Angle EBG is 90 degrees. So alpha plus beta is 90 degrees. On the other hand, we have the square ABCD. So we have beta plus gamma is equal to 90 degrees. Okay. So you know that both of these are 90 degrees. They have common alpha. That implies alpha, common beta. That implies alpha equals gamma. Angle alpha equals angle gamma. So that we can conclude these two right triangles are similar. Triangle BEA is similar to triangle BCG. Now we can apply the similarity. They have the common ratio for corresponding sides to solve EB. EB corresponds to the longer leg. So BE over, and the longer leg in BCG is BC. That's equivalent to the ratio of their hypotenuses. So it's BA over BG. So we have BE over BC. Okay, BC is 4 equals to BA is 4 over BG. BG is 5. Now we have BE equals 16 over 5. The answer here is 16 over 5. Let's do question 24 in AMC10 grading system. The correct answer was 6 points. An unanswered question was 1.5 points. A wrong answer was nothing. So if someone got 93, what's the largest possible number of wrong answers? All right, let's assume the number of wrong answers to be x, and the number of correct answers to be y, and the rest questions are unanswered. So number of third question, that it should be 25 minus x minus y. And here we should require that x plus y is at most 25. Okay. Now let's check the total grade. A wrong answer was nothing, so 0 times x. The correct answer is 6 points, so 6y, and plus unanswered question, okay, 1.5 times 25 minus x minus y. That's the total score, which is equal to 93 in this question. The problem here is asking what's the largest x? Largest x. That's the question here. Now let's study this equation. Here we have this equation simplified into the following one. We can times 2 and then divide by 3. So finally, this equation can be simplified into minus x plus 3y equals 37. So based on this equation, we have that x equals 3y minus 37. So x is non-negative, so y is at least 13. Y is at least 13. So let's discuss. First case, if y equals 13, now we have x equals 2, right? 39 minus 37 equals 2, which is good, okay? Which is good because 13 plus 2 equals 15 is less than 25, which is good. But the question is asking for largest x, so let's try more. Second case, if y is bigger, like 14, then we have x equals 5. 42 minus 37, 5. And this time is also good because 14 plus 5 is 19. 19 is less than 25. it's still allowed. Third case, if y equals 15, then we have x equals 8. So we have 15 plus 8 is 23, which is less than 25. Still good. And it seems that this should be the largest one. But let's check if y is slightly bigger, 16. Now you should have x to be 11. Okay, 11. So this time, 16 plus 11 equals 27. It's already bigger than 25. That's not allowed. So we can imagine if y is bigger and x is also bigger, so x plus y, they are bigger than 25. So far, we see the largest value of x appears in the third case, and the value is x equals 8. So the answer to this question is 8. Question 25. Frank has 5 different pairs of shoes in his closet. So there are totally 10 shoes. Let's mark these pairs to be AA pair, BB pair, CC pair, DD pair, and E pair. Okay. So he randomly select 4 shoes. So we can consider how many ways he can select 4 shoes. Number of ways to select 4 shoes, which is just 10 choose 4. 10 shoes, I choose 4. 10 choose 4, which is 10 factorial over 4 factorial, 6 factorial. It turns out to be 210. There are 210 ways to choose 4 shoes. The question is, what's the probability that there will be at least one complete pair? At least one complete pair. So he selected 4 shoes. There are 2 cases. Maybe there's 1 pair, and it's also possible there are 2 pairs. And if we can do the discussion, but it's easier if we can consider the complement. So let's consider the complement. The complement case means no pair. They don't make a pair. And let's see how many cases to have such a result. So no pair, 4 shoes. That means these 4 shoes come from 4 different pairs. So we should consider which 4 pairs are have one shoe selected. Which 4 pair? So there are 5 pairs. Now I choose 4. 5 choose 4. Once we determined which 4 pairs they have some shoes selected, we can ask which 4 shoes are selected. Now, each pair there are 2 shoes. Either shoe will be fine in this scenario. So like the first shoe, there are 2 choices. Second shoe, there are 2 choices. Third shoes, there are 2 choices. And the fourth shoes, there are 2 choices. So there are 2 to the 4th, 16 ways to determine these 4 shoes based on the previous step. Now by multiplication principle, we multiply these 2 steps, and it corresponds to 5 times 16, which is 80. In other words, there are 80 ways to select 4 shoes without a complete pair. So the answer to this question should be complement of this probability. 1 minus 80 over 210, which is 130 over 210, simplifies to 13 over 21. The answer to this question is 13 over 21.